So far, we were discussing about how to write the neural networks from scratch. We used to use the neural networks in such a way that we used to design the neural networks, right? So from scratch, the code was written, to implement the layers of the neural network. Right? That's what we used to do so far. But today, we'll take a deviation from there and we'll see how to use the uh, Matlab inbuilt functions so that we can use them to design the neural networks. Okay, right. The advantage is that we will be able to, the advantage of using the inbuilt commands is that we will be able to visualize the neural network as well. Okay, so we use inbuilt MATLAB commands to design the neural networks. Okay, so because of the inbuilt functions, they also support the what is called as the visualization. We can visualize the neural network. So we will build the custom neural networks and we will learn how to use those custom neural networks. Okay, this is the primary goal today. So we are going to use the commands or the functions directly from the neural network toolbox. Okay, so the first idea is that, right, we will see how to create a neural network, right, which basically is a custom neural network, right? I want to design the neural network how I want. So I'll go for a new script. My custom in. So maybe we'll do many such. We'll design many such neural networks today. That's why, right? I'll call this as a first customized neural network. Okay, so our objective is to define some input, define some output, and design the neural network which performs the training of, right, trainings corresponding to those inputs and outputs. Okay, now I also use the compactive. Okay, let me define some inputs and outputs. Input is equal to 1:6 transpose output is equal to, let me define some output. This is 1 space 2 transpose. All right, so let us just check what this is going to do. I'll remove the semicolon so that I can see the output. So I can see that the input and outputs are like this. Okay, now I'll put the semicolons back so that when I run next time, the output is suppressed. Okay, so now you see we'll design the neural network. So designing the neural network is very simple using the inbuilt command, right? So to first I need to create before I train, right? So let me write what I'm trying to do here is creating the ANN using the built-in commands. So You see, the first technique is I define my neural network as any name you can give, right? I'll call it as a a. My neural is equal to, see, the command to create a network is network. Okay, so let's just check out the help. Okay, so help network. So this should give you an idea about, right? What is a network? So a network is create a customized artificial neural network, right? So what are the various parameters you can pass it to this? The number of inputs, number of layers, bias, connect, input connect, and the layer connect, as well as the output connect. So these are the various parameters you can pass. This takes so many inputs and returns a neural network. Okay, there are some specifications to be met. Let us see now. So input is number of inputs. Number of layers is how many layers you want. The bias connect is, right. It's a number of layers in by one Boolean vectors, comma zeros. So you see that it's like that, right? So input connect. But so I'll tell you what is a bias connect. Bias connect is basically you can provide the information to the machine that I want to design a neural network such a way that the bias is present for so many layers. That's what you specify, number of layers by one. Okay. Then input connect. Input is connected to which all layers? It's not necessary that input has to be connected to only to the first hidden layer. Input can also be connected to the second hidden layer and third and so, right? You can design in any way. So wherever you connect, you will write, it's a Boolean matrix. So wherever you write one, it assumes a connection there. Wherever you write zero, there is no connection. Then the layer connect, right? Which layer is connected to which layer you can decide. And the output layer is also in the same way. From which layer you are taking the outputs, you are going to specify in this. So if you, right, you have the complete freedom to decide which layers you want to decide. Others, you can leave it uh, to take the default values. Okay, so if for example you provide only the first two values, indicate that you are creating a neural network of one input, two hidden layers. One input, two layers, right? You can see you can design something like this. One input, two layers, one colon, one semicolon zero indicates that only one layer has the input, right? Input connected to this, right? Then you can see the next one says that where are the biases? Bias is connected only to the first one. Second layer has no bias. Okay. Then you see the layer connects, right? So 0, 0 is 1, 1. 0, 0 is index is 1, 1, 1, 2, 2, 1, 2, 2. So 2, 1 is 1 here. So 2, 1 indicates one is output of 1 is connected to the next layer. That's all. That's the only connection you have. Okay. And the output is collected from the second, right? So not the first value is not connected to output. Only this says that you are connecting the second value. Okay, so this is how we try to design. I'll show you how to visualize this. We have many options available here. So anyway, when you have time, you can go through this and you can understand, right, how this is done. Again, I can look at the doc as well. So when you press the doc, you can see that the documentation opens up related to the network. Again, you have the complete details available over. What are the various parameters you can give as input, and right, how to modify. Right here itself, you have have a list of examples as well, right? Just to see that, right? What are the various options you have? How do you train, right? The neural networks, etc. Right? Okay. When you have time, please go through that. That's very helpful in understanding the concepts and the program. Okay, so let's go ahead. Now, for this particular problem where I have defined the neural network of this type, right, let me design some. Let me decide, okay, I have right? All the 6 values are inputs, right? They go at once. So I need one input layer. Okay, so 1 is the number of layers in the input, comma. So I try to go to the next line. I want to type. Okay, so that's 1 for the number of inputs. Okay, then I'll write 2. I want to design a neural network with the 2 input layers, 2 output layers. My mistake. Number 2 layers basically, right? 2 hidden layers. Then I have to talk about the bias connect, right? So just refer to this. So let's see here what I'm trying to. Okay, right? So number of inputs 1. Next entry will be the number of layers. Now I have to say the bias connect. Just see here how the biases are connected. Which layers has bias, which layers have bias, which layers don't have bias. I need to specify. Okay, I want to make sure that my first layer has some bias values. The second layer has no bias. So this is 1 and 0, indicating that the second layer has no bias. Okay, I think I need a comma over here. So let me make this a comma for bias. Okay, so that's how the bias connection. So you can see the requirement also. It says that the requirement is that bias connect is number of layers, that so many by one Boolean vector, right? It's number of rows should be equal to the number of layers. How many layers, how many rows should have? It should have 2 because I have 2 layers, correct? So total layers designed in this case is 2. So I should have 2 into 1. So I did that. So go ahead. So next one is input connect. So number of layers by number of inputs. So number of layers is 2 and number of inputs is 1. So this has to be a 2 into 1 matrix, what I'm going to enter now. And I'm specifying input connect. Input connect to which layer input is connected. Correct? So to which layer I want to connect? I want to connect the input only to the first layer, not to the second. Close this, comma, put a new. Okay, that's done. Next, look at the requirement. Then I need to say the specification I require for the layer connect. Which layer is connected to which layer? Okay, so it is number of layers into number of layers. There are 2 layers. You may have first layer output connected to second, right? These are the options. First layer's output connected to the first layer, 1, 1. First layer to the second layer. Okay, second layer's output to the first layer, second layer output to the second layer. These are the options. That's why you have number of layers into number of layers. So the next entry that I'm going to write here, right, should be 2 into 2 matrix. Okay, that will be right. So this is what is my entry. Let's analyze this later. So I'm going to enter it like 0, 0. Then the next entry will be 1 followed by a 0. Close this, comma. Okay, so the meaning is like this. You see, output of the first layer is connected to the second layer. That's all. I don't have any other connection. So the index 0, sorry, index 1, 1 is 0. 1's output is not connected to 1. So this is 1, 2. So 1, 2 means 2's output is connected to 1. Is it true? No, that's why it is. So then this is 2, 1. 2, 1 means output of 1 is connected to the second. Yes, that's why it is true. And 2, 2 is 0, indicating that output of the second layer is not connected to the second layer. If you want, you can make this one. So you can specify what you want, like this. Okay, so that is the layer connect. So after layer connect, you have output connect. So that is 1 by number of layers. One row, number of columns equal to number of layers. So whichever layer provides the output, you just make that 1. Others you keep it as 0. Okay, so it is one row, right, first layer is not providing output, but second layer is yes providing output. That's why you write it like this. All right. So I close my function. All right. Let's check whether this is going to. Let me say or something. Let's see. Okay, it says use delimiters. Let me take this. I need to use. Now that's. Now you can see a neural network object has been created. So anyway, we will not be able to see the details because it has not been initialized. A neural network has been created. So what I do, I'll directly, if you want to visualize what you have created, yes, you have one option, and that is view. This option is not there when we design. That's why I told, right, if we use the inbuilt commands and you build using the the neural network and machine learning toolbox, if you use like this, you can visualize. So I want to visualize my yeah. So let's run this. It creates that, and you can see that there is a neural network. Right. So when you click on this, you can see the network. Right. The neural network will have so many hidden layers. Right. As you decide, you have defined as you have designed, and you can also visualize that. Now let's say in a first layer, how many neurons are there? That's what is my next objective. Okay, for the time being, anyway, I don't want to visualize every time, so I'll make this a comment. But anyway, it's optional. You can visualize as and when you want. Now I need to specify how many neurons are there in each of the hidden layers and what is the activation function I'm supposed to use. Okay, so I'll come to the MATLAB. So let's try to write. So the whatever is the network you have designed, you will use that as an object. So ANN, I think my ANN dot. So use the dot notation. You want to access the layers. Okay. In that first layer. So we use braces over here. You can access the size. So dot size. Define that is equal to maybe I will go with 5, but anyway, let me check how many are there by default. My ANN dot layers. You can see the details now. 2 into 1 cell, right? So this is what is the detail. What it actually, you can see that I didn't run this part of the code, so it's still showing the default values, right? So let me go with my layers uh, of 1. Let's see the details. So you can see that, right? This is the what is the detail corresponding to the neural network that is by default. So first layer, right? It has a uh, it has no dimension. Nothing is initialized. You can see that the input function is net sum. You can see transfer function is purely. I will show you that how to change this. Okay, whatever you want, you can. But this is the initial uh, values. So I can definitely do the same thing with the second layer. Let's just check what is there. So second one is this is the default values, right? Still we have the default values. Okay, right now you see I'll run this. Now this actually changes. So okay, I'll run afterwards. So I'll also give another specification. And I want to make sure that this layer's transfer function is log sig, right? When we just saw it was pure lin, I'll change it to log sig, right? So net, not net, sorry, it's my ann dot layers. So use braces one dot. Now I don't want size, I want to transfer function, right? So this is transferFCN is an identifier to identify the transfer function. So give the name as character array. Okay, so which you want log sig. We know that how to use this. We already have seen in the initial classes. First few classes we looked at this, right? So what is a log sig? Then once again you want to view, you can go for view my aim. Okay, all right. So let's run this. You can see that, right? It's visible now. So anyway, I'll make this as a comment because I don't want this to run every time. But my preferred way is that I want to visualize the my ANN1 and okay, let me check the layers. Now you see the layers. It has been changed. You can see that there are 5 layers and the function has been changed to boxing. We didn't touch others, so right, other parameters still are same. Okay, now so this is what I did for the first layer, right? Now what I do, right? Output, I don't want to change anything related to the output, right? And maybe I'll directly start with the configuration of the neural. In a sense, configure your neural network according to the requirement. I just built the neural network. So my next objective is perform the configuration or configure the ENN. So how to do that, right? Mm, Don't change the name. My ENN is equal to call a built-in function called configure. Configure what you want to configure. Configure the my ANN by providing, right, set the change, set the input parameters like the number of layers, number of connections required, which layer to be connected to which layer, everything we defined, but now I'm asking the machine to make the changes accordingly. So the input, I think it's just the input comma output. So use all these variables we defined and configure the. Once you configure again, you can perform the my, right. So that will show you what are the changes made as per the most recent. Okay, once the configuration is over, now you can directly go with the training of the neural network. Okay, so training, you don't have to initialize any of the weights, etc. You see here, that's the advantage because neural network will perform it. The built-in commands will take care of that. Okay, when I said configure, configuration will do the initialization of the weights, biases, etc. as per the designed. So you see, it's pretty straightforward. It's easy. Okay, now I'll go for a training. But before training, what is the output? I just want to check. Okay, so because before training and after training, I'll verify. Okay, so I'll write here. This is calculate the output without training. So I'll write it as initial output is equal to how to calculate. It's very simple. Simply right, do the network, give the inputs to your neural network, that is my ANN of the input. Okay, let's check this, then I'll come into this. You see, initial output is coming as of now. We have not done any training, so it comes as 0 0. Output expected is what? 1 2, right? You get 0 0. Fine, it's okay, it's acceptable. You can get any output, no problem. But after training, I'm expecting the required output. That's right. So now we'll go for the training option. Okay, so the first I have to perform the training. Before I train, I have to specify what type of training I. Now you understand the various functions, okay, related to the training. So what I do, I'll give the specifications, what I want, how the training should be done, what particular algorithm needs to be used. So my ANN dot, that's the new name of the network I have created, dot training function, right? There are many options available. You can see the help, the out of which I'm going to use one of them called, it's a train LM, one of the very famous algorithm available. Training function, weight updation function, that is available. Okay, you can use others. We know many things: stochastic gradient descent, right? Back propagation of errors, etc. Many things are there you can use. Okay, right. I just wanted to show how to use, how to utilize it. So this is one option. Then let's go further. So how do you measure the performance? That's important, right? Error calculation is important, right? So the in this particular neural networks training, it's a perform function, which is a performance measuring function you want to use. Mean square error. Okay, I mix it, right? Then call my ANN is equal to train. I already defined what I want, so simply call the train function. Train using the already existing my ANN, comma, input and output. So it's the same input and the desired value. Okay, input and output. All right, the training happens. Let's check out. So you can see the training happens like this. And once the training is over, right, I can actually check my output. So I'll just write another code here before. Okay, so that was the initial output. Previously we wrote the initial output summary. Yeah. So now I'll write the final output. Do the same thing. My ANN of input. Okay, so now we should get the initial as well as the final. Okay, I just okay. Now let's try to save this, and you can see the final output as well, right? You can see the final output is 1 2, which is the required, correct? So we said that output required is 1 2, right? So you can see that the customized neural network built using the inbuilt commands of the neural network toolbox, right? Efficiently produced the neural network of our requirement, and also it produced the it actually performed the training in a very good fashion, and you got the results. Are you okay? So that was first thing, right? I wanted to show you. Right, let's move further. Next one, we'll go to slightly complicated problem, how to design the required neural network, and how to train and test. We'll see that later now. Okay, fine. So, okay, let me go for another script. This is my custom ALM second. All right, now uh, our objective now is to classify linearly separable data with a perceptron model. Okay, so let me just write to design perceptron classifier. It's a type of a neural network, uh, to separate linear data. Okay, okay, I can say that linearly to classify the linearly separable data. So as of now, I don't have any such data. I have to create the data first. Okay, so let us do something using the coding itself. We'll generate. Okay, so let me try to define the num of samples is equal to 50, right? I want to create 50 data points in each of the class. Okay, so that's why. And let me define a offset value is equal to say 10. This is the offset between the first and the second data, right? So there are two data sets I'm creating. So let's see how to create that. So first one, x value is equal to, I have to create two sets of x values. Okay, so this is x is equal to, I'll create uh, an array that is, it's a random numbers of between okay, say 2 comma num of samples space. After this, I want to create first 50 samples like this. Okay. And the next 50 samples from the second class. So it's once again, see, I'm creating at random numbers, 2, comma, number of samples. But you see, to this number, I add my offset. Okay. Offset value. So I'll just show you what exactly is happening here. Now, actually, you can see that, right? X has been created. So I told I'm creating two classes, right? Two classes such a way that I can separate them by using a straight line. Okay. Now, the two classes are there in this data. They are again, I just created the X values, not the Y coordinates. I'll come to the Y coordinate later. Okay. X coordinate is defined in such a way that uh, there are two classes. In each class, I have 50 samples. Okay. So 50 plus 50 total 100. You can see that X is equal to 2 into 100. It's a double data. Two rows, 100 columns. How did you make 100 columns? I created first 50 samples using this. Two rows, 50 columns. You see random numbers, 2 comma number of samples. Number of samples is 50. So two rows, 50 from here. To that, on the right hand side, right, I appended, right, I concatenated another matrix. Again, it is of size 2 comma 50, but to that numbers I actually added my offset value of 10. So 10 more than these numbers will be there. Let's just check. So you can see that first, you see the values are like this, okay, up to the 50th one. So immediately after 51, you can see the increase in the numbers. You see this data is like smaller values, 1, -1, something. All of a sudden, 51 onwards, they jump into a bigger value, right? Because I added the 10 to that, right? I added the offset value of 10. This is why the the classes have been created, right? It's the easiest way to create a class. Okay. Now, let me create the output. As of now, I don't have any output, right? These are my input values. That's all. So I'll create the output now. So in order to create the output, so let me call it as a y. Or, or even I can give the name as input and output. That makes more sense. This is the input, and instead of giving y, I'll give a proper name. Okay, so this is output. As of now, I don't have any output, right? So what I can do, I just want to save the space for the outputs. Okay, so this is zeros. What are the classes you require? So for whenever the input is given from the class, first class, that is whenever any of the first 50 numbers given as input, I want the output should be 0. Okay, so zeros of 1 comma, right, the number of samples, right? Whenever the data is given from the next class, that is any data is given from 51st one till 100, right? I want to, it's a different class, correct? That's a completely different class. So what you do, you make it as 1. Output required or the desired value is 1. 1, oh, same thing, number of samples. Okay, so let's quickly run this to check this. Now you see output has been created. So in the output, first 50 numbers are zeros. Okay, you can see that till here it's 0. As soon as 51, everything changes to 1, 1, 1, 1 up to 100. All right, so yes. Okay, so we defined inputs and outputs. So what I want to do now, I want to visualize. Okay. To visualize, we have one. Okay, I'll call it figure. And it's a plot, but since it is a perceptron values, there is a specific plot of the input samples by using perceptron vectors. So the command is slightly different now. Plot PV. This is inbuilt command in the machine learning, ANN machine learning tool. Okay, so plot PV. What you want to plot? The inputs versus the outputs. I think it's just a singular input versus output. Let's check whether we can see something. Yes, you can see, right? So the plot is visible, right? It automatically adds two classes, right? It does not plot everything with the same markers. You can see the markers are different. That's why I said, so to these numbers which are centered around 0, I add 10, right? So you can see this is centered around 10 comma 10, right? You added a bias, right? So because of that, right, we can see this is happening. All right, fine. Okay, let's move further. Now, the next intention is define the network, right? As I told, I'm going to use a perceptron classifier. So to define such a network called perceptron, right, there is a inbuilt command. You don't have to define even the number of layers, hidden layers, connections, etc. You don't have to worry, right? Perceptron is again an inbuilt command. Okay, so that is, in this case, my neural network is equal to perceptron. Just define that I want to use a perceptron here. Then is equal to directly perform the training. Train my neural network, input, output. Okay, let's do the training. Okay, spelling mistake, my mistake. Sorry. Yes. P-T-R-O-N. Yes, let's N-E-R-C-E-P-T-R. Sorry, once again, Perceptron. Yeah, okay, it runs. So once the training is over, definitely I'll just add another comment over here. If you want, you can see. Okay, so that is view my neural network. All right. So anyway, I don't want to see that. I understood. Now I just want to visualize, right, the plot. I'll go for I'll in the same figure. I also want to plot something. Okay, so that is, I just want to visualize the weights and the bias, that straight line which comes from the weights and the bias, right? If you remember, in the neural network, when we discuss about the neural networks in the basics of neural network class, specifically the theory, we try to plot a straight line which classifies, right, which classifies the two uh, sets of data, correct? So if you, for example, maybe an XOR, maybe, sorry, not XOR, maybe a AND gate, OR gate, something like that, right? In such problems, we try to apply uh, the trained values, weights and biases to get a straight line equation, right? So that is actually valid here, right? Even the MATLAB supports to plot that. So I'll plot PC, right? It's not always the plot function. Plotting of the decision boundaries by using plot PC function. All right, so this is my ANN dot, right? You have to use the IW. This is the weights. Use the weights again of using the braces, specify which layer. There is only one input and one. There is only one layer defined now, so that's what. It's just one. Then net. Uh, it's not net. Net is the inbuilt parameter. So I have changed it to my ANN dot. Now you see the bias. If you want to visualize it, it is B of 1. All right. Now let us see what we are going to get. So you can see a straight line being plotted now, isn't it? Can you see a straight line that is additional compared to the previous one? So that straight line is what is an indication that okay, this is how you can classify, right? The two classes, right? We define two. Is this the only answer? No, there are infinite solutions, right? Out of which one of the answers MATLAB has given us. All right. So actually, you can see now what I do. I'll run this once again. Okay, when I run this, I'm expecting a different graph now. So you see, right? Because the data set is different, you are getting a different graph. Let's run once again. So just see now, the plot you can see is completely different compared to the previous one because even the data set has been changed because we are generating it at random, right? So like this, we can use the MATLAB inbuilt commands present inside the uh, machine learning and neural network toolbox to implement the customized neural network, right? Previous example was a simple neural network, right? Uh, how to give the specifications of the neural network manually, right? But using the inbuilt function. And now we used a standard model called Perceptron, right? And we trained it to classify linearly separable class like this.